Alright, so chapter 13, section 4. What we're going to be doing today is we are still using our unit circle. So if you have it, get it out. And I hope everybody had it for the quiz yesterday. So everything we've been working with so far has been like, I've been asking you to find like the tangent of 120 degrees, right? And then you use the fact that tangent is sine over cosine, right? And you take the sine value divided by the cosine value. What we're going to be doing today is we're going to be going backwards. So I'm going to be giving you like 1/2. And I'm going to be asking you what is the arc cosine of 1/2, or what is the inverse cosine. Okay? So we're going to be going, instead of from the angle to the measurement, we're going to be going from the measurement, the x and y coordinate, back to the angle. All right? So you are still going to be using your unit circle. So make sure you have that out and you're ready to go. So this is actually a really short lesson. The hard part is getting your head around it. So let's take a look. Evaluate cosine of the negative first. So whenever you see the negative first power on a function, it means inverse. So this is actually read in two ways. This is read as the inverse cosine or the arc cosine. Okay, I tend to use the phrase arc, but it means the same thing. Okay, so if cosine of this angle gives us a value, right, the arc cosine of that value is going to work us backwards to find us the angle. So the answers out of an inverse sine, inverse cosine are going to be the angle measure that has the cosine of the value that's inside the parentheses. So if I asked you to find arc cosine, so real quick, this means inverse cosine, right? So what this is going to tell me is I want to know what angle measure has a cosine of square root of 3 over 2. That's what I'm really trying to figure out, okay? The arc cosine will tell me what angle has a cosine of square root of 3 over 2. So, cosine, is that an x-coordinate or a y-coordinate? X, right? So look at your unit circle. Which angle measure has an x-coordinate of square root of 3 over 2 in the first quadrant? 30 degrees. Does everybody see that? I have an x-coordinate of square root of 3 over 2 right here, which means that the arc so like the cosine of 30 degrees is square root of 3 over 2, right? The arc cosine of square root of 3 over 2 will be 30 degrees. So they're inverses of each other. One goes from angle to measurement, one goes from measurement back to the angle. The answer to this is going to be 30 degrees plus, is there anywhere else up here where I have an x-coordinate of square root of 3 over 2? 330 degrees, right? Okay, so we're going to get two answers here, right? So I'm at 30 degrees, but do I know how many rotations I'm going to make to get to 30 degrees? No, so like if I'm at 30 degrees, the arc cosine of square root of 3 over 2 is 30 degrees. What's the arc cosine of 390 degrees? That's still going to be square root of 3 over 2, right? What's the cosine of another rotation? Still square root of 3 over 2, right? So how many solutions do I actually get here? How many times can I rotate around a circle? Infinite. So there's actually an infinitely many number of solutions. So how I mark that is I take the value off my table, or off my unit circle, and I just put in 360n. And all that means, and this is 360 degrees, okay, n is just a number. So that means that I can do as many rotations forward as I want, or as many rotations backward as I want. Okay, this is called a general solution because we don't know exactly what angles we're looking for. Okay, we don't have any bounds right now, so we have to keep it open for all solutions. And that's what that 360n does. Okay, so everybody okay with how I got the 30 degree? And then the 360n just means infinite rotations. So like, if I wanted to, I could go 5 full rotations around the circle and then go 30 degrees, right? That would still be an angle whose cosine is square root of 3 over 2. So any time that I have an angle that is coterminal to 30 degrees, I'm going to get a cosine of square root of 3 over 2. So I have to figure out how do I write 30 degrees and then as many rotations from there as I want to do in any direction. And how we write that is the 360 degree n. So first quadrant is 30 degrees, right? And then there was another place where the cosine was square root of 3 over 2. Where was that? 330. So I have to include that as a solution as well. Okay, so how am I going to write it out, though? 330 degrees what? Plus 360 degrees n. Again, I have an infinite number of rotations from that 330 point. Okay, but is everybody all right with how I'm getting the 30 and the 330? Right, this is the big key, and then the 360 n just kind of becomes something you include. All right, but the 30 and the 330 is what really matters. Is everybody okay with where I'm getting those from? So what I'm trying to figure out is what angle measure has a sine equal to 2. That's what I'm really trying to figure out. When I say what's the arc sine of 2, I'm asking you what angle measure has a sine that's 2. So what I do is I go back to my unit circle. All right? That's got all of my possible solutions. So that's what I'm going to be using as a reference point. If I can't do it with that, then I'll eventually use a calculator, and we'll get into that. So let's take a look. Which coordinate is sine? X or Y? Y. Okay, so I'm looking at my Y coordinates, right? 0, 1/2, square root of 2 over 2, right? Are any of these 2? Okay, so is there anywhere on the unit circle that I can exist that has an arc sine of 2? No, because sine and cosine have to be less than 1. So there's no angle that exists that has an arc sine of 2. So you can just put does not exist. There is no arc sine of 2. All right, so arctangent negative square root of 3. Now, this one's going to be really difficult, so I'm going to change things a little bit. We've discussed how to find the tangent of these angles, right? It's right here. So if you don't have this written down, write it down. But have I actually gone through and written out what my tangents are? No, so I'm actually going to do that. All right, so since I haven't written out what the tangents are, we're going to actually just hand calculate here. So if I wanted to know what's the tangent of 0 degrees, right? Again, tangent is what over what? Well, it's sine over cosine, right? And which one is sine, x or y? Y, so it's y over x. So for 0, what's my y coordinate? 0, and what's my x coordinate? And what's 0 divided by 1? 0. So the tangent of 0 is 0. Okay, so these are the tangents for the first quadrant. If we know these, we know everything. Okay? So again, you said tangent is sine over cosine, right? Which is y coordinate over x coordinate. So for tangent of 0, the y coordinate is 0, the x coordinate is 1. So you get a tangent of 0, right? So the tangent of 0 degrees is 0. So what would be the arctangent of 0? 0 degrees. Is everybody okay with how this works? So tangent moves us from left to right. Arctangent would move us from the value back to the angle. All right, is everybody okay with that? Because every year I teach this, I have kids who like arctan or arccosine, and you get a number when it's got to be an angle measure. So tangent of 30 degrees, again, sine over cosine, right? You said that the sine was 1/2, and the cosine was square root of 3 over 2, right? Okay. Yeah. So everybody okay with how I get to here? So I take the numerator, multiplied by the reciprocal of the denominator, right? All right, so can anything cancel? Okay, the 2's. So I get 1 over the square root of 3, which can't happen. I need to rationalize. So I get square root of 3 over 3 for my tangent. Okay, tangent of 45 degrees. Sine over cosine. What's anything divided by itself? 1. So the tangent of 45 degrees is 1. 60. What's the sine of 60? Okay, and what's the cosine? All right, so this is the reciprocal of 30, right? So we get square root of 3 over 2 times 2 over 1. Can anything cancel? The 2's, and what do I get left with? Square root of 3. Okay, for 90, what is the sine of 90 degrees? 1. And what's the cosine of 90 degrees? Okay, what's 1 divided by 0? Can I divide by 0? No, so what is it? Undefined. All right, so these are your tangents. Is everybody okay with that? Yes or no? So like I said, we now have enough to where we can fill in the entire chart. So the tangent of 0 is 0, the tangent of 30 is square root of 3 over 3, the tangent of 45 is 1, the tangent of 60 is square root of 3, the tangent of 90 is undefined. So if I come over here, okay, so everybody got those added to their unit circle. So again, if we know the first quadrant, right, this is the tangent of 0 is 0, so what's the tangent of 180 going to be? It's going to be the same thing, right? They're reference angles. So the tangent of 180 is 0. What is the tangent of 30 degrees? Square root of 3 over 3. So what is the tangent of 150 degrees? Close. Is tangent positive or negative in the second? It's negative, so it'll be negative square root of 3 over 3, right? Because you're going to wind up with a positive divided by a negative. All right, everybody okay with tangent of 150 being negative square root of 3 over 3? All right, what's the tangent of 45? 1. So what's the tangent of 135? Negative 1. What's the tangent of 60? Square root of 3. So what's the tangent of 120? Negative square root of 3. So any questions on the first two quadrants? Okay, so let's go down to 210 degrees, right? What's the reference angle for 210 degrees? 30 degrees, right? So what is the tangent of 30 degrees? Square root of 3 over 3. So what's the tangent of 210 degrees? Square root of 3, because tangent's positive in the third quadrant. So the tangent of 210 is square root of 3 over 3. The tangent of 225 is 1. And the tangent of 240 is square root of 3. Everybody okay with how I'm building this or no? So it's all about going back to the first quadrant. All right. So 270, what does it match with? What's its reference angle? 90, right? So what was the tangent of 90? So what's the tangent of 270? Undefined. Okay. So we'll finish up fourth quadrant. So is tangent positive or negative in the fourth? Negative. So we should be getting negative answers, but they'll be the same answers. So 300 degrees matches to what in the first quadrant? 60. So what's the tangent of 60? Well, 60 is positive square root of 3, right? So what's the tangent of 300? Yeah, negative square root of 3. Everybody okay with that connection? Yes, no? All right, so the tangent of 315 is negative 1, and the tangent of 330 is negative square root of 3 over 3. So is everybody okay with how I'm drawing these connections off the unit circle? So it's the same thing that we did with reference angles. Okay, if you know the first quadrant, everything else opens up. So now, back to the whole point of this, if I gave you a problem like number 3 here, arc tangent negative square root of 3, I want to know what angle has a tangent that's negative square root of 3. So first of all, what quadrants is tangent negative in? Second and fourth. So how many answers am I going to have? 2. I'm going to have 1 in the second, 1 in the fourth quadrant. So let's just look at the second quadrant. So second quadrant, tangent of negative square root of 3 is 120 degrees, right? Everybody okay with that? Yes, no, right? That's what you have written down on your sheets. So I come back over here, and I can't just write 120 degrees because that's only one answer out of the infinite. So how do I get all the other ones? So and then for fourth quadrant, what angle measure has a tangent of negative square root of 3 in the fourth? 300. So I get the 300 plus 360. Yeah. If I have tangent theta equals square root of 3 over 3, right? And I asked you to solve this. What does it mean to solve an equation? To get what by itself? The variable. So in this case, what is it? Theta, right? I want to get theta by itself. So what is it that we have to get rid of? Tangent. Okay, tangent is a function, right? So how do we get rid of squaring? We square root. How do you get rid of square root? You square. Okay, so now real quick, look at your calculators. So if you notice, right, what's written right above your square button? Square root. Those are set up that way for a reason, okay? It's not like, we're not trying to be sneaky. Yeah, believe it or not, Texas Instruments set it up so that way the second of the button is its inverse. So that's what should be undoing each other. So if I wanted to get rid of tangent, what option am I going to hit on your calculator? Tangent to the negative first, which is what we call inverse tangent or arc tangent. So when we distribute this, we get arc tangent of theta equals arc tangent square root of 3 over 3. So what happens when you square root a square? What do? It cancels out, right? What happens when you square a square root? It cancels out. So what do you think happens when you inverse tan a tan? The tangents cancel out and leave you with just the theta, which is what we're trying to do, right? So this is the only job that arc sine, arc cosine, arc tangent, arc cosecant, arc secant, arc cotangent have. Their job is simply to remove the trig function while we're solving. And then this is what we did on the other side, and you'll get 30 degrees. Right? Everybody okay with that? Yes, no, maybe? So everybody okay with how this is going to work? All right, so let's actually look at the last bit here, which is actually solving these. Now, if you notice, I have a trigonometric statement, right? Sine of theta equals negative 5/8. And I want you, if you notice, I've got sine of theta equals negative 5/8, right? So this is where I'm going to be using my calculator because do I have a negative 5/8 anywhere in my unit circle? No, so this is not going to be one of my common angle measures, so I'm going to trust my good old calculator to find it for me. Everybody all right? Okay. Now, if you notice, what do they tell me? Where's theta? Between what and what? 180 and 270. This is actually really, really, really important. Because remember when we were doing the general equations, right? There were an infinite number of options. I'm looking for just one. So, first of all, which trig function is this? Sine. And it's negative, right? Sine is only in the third quadrant. We're only in the third quadrant where sine is negative. Everybody okay with that? Yes or no? All right, so just like before, how do I get theta by itself here? Okay, inverse sine of both sides, which means these cancel, and I get theta is equal to inverse sine of negative 5/8. Now, again, negative 5/8 is not one of our common angles, so you're going to have to use your calculator. So you just type it in. Make sure you're in degree mode. And what is the arc sine of negative 5/8? Negative 38.6821. Okay. So let me draw this out to see if I can explain it to you all, because this is really tricky stuff. What quadrant do we have to be in? Third, because we're locked down between 180 and 270, right? So this is where I have to be, is in the third, right? Now, when you ran this through the calculator, what did you get for an angle measure? Negative 38.6821 degrees, right? Where is negative 38.6821? That's somewhere here, right? That's in the fourth quadrant. Is that the quadrant we need? No. So this is where we're going to use our reference angle idea. So if the distance from 180 to here, from 0 to here is negative 38.6821 degrees, right? What do I need to use as my reference angle over here in the quadrant I want? Okay, so it'll be 38.6821 degrees. Is everybody okay with that? Yes, no, maybe? All right, so how many degrees is this right here, the x-axis? That's 180, right? So how many total degrees to get from here all the way around to here? Oh, yeah, so what's 180 plus 38? 218, right? So 218.6821 degrees, and this is your answer. Okay, so because your calculator will always spit out an angle less than 90 degrees if it exists. So it's going to be spitting out angles in either the first quadrant or the fourth quadrant. So what we're going to have to do is use our understanding of a reference angle in order to put it in the appropriate quadrant. So we got the angle in the fourth quadrant is negative 38.6821 degrees, right? The important thing here is that the distance between the x-axis and our terminal side has to be the exact same distance as the x-axis to our terminal side in the quadrant we actually want. Is everybody okay with that connection, yes or no? So if you notice, 38.6821, 38.6821. So I'm trying to figure out how many degrees to go from 0 all the way around to the terminal side in the third quadrant. So I'm 180 plus my angle that the calculator spit out. So the weird part about this is tracking which quadrant you're in. So you're going to have to know, if they give you two options, right? If they would have said in the second, like between 90 and 270, where is sign negative, in the second quadrant or in the third quadrant? Third, so you know that it's 180 plus the reference angle because we have to drop down into the third quadrant.